Okay, so welcome to Discuss That User Group. We've got Eddie here. He's going to do a great talk about, tech amendments.
Yeah. Okay. Hi, everyone. I'm Eddie Lichtman, a Wisconsin-based senior software engineer and self-proclaimed software librarian at this point, focused on developer experience. I fill my free time with other hobbies such as making wine, pickling, and playing trombone in a British brass band. We actually have a concert coming up later this month. Feel free to chat with me after if you're interested. But my true passion and calling is my enthusiasm for defining and improving the process for my fellow developers. So I heard a saying at that conference recently, which is, developers want to do two things: build something useful and leave. So how much cruft do you have to sift through day after day to build something useful? How much debt do you accumulate from the sheer quantity of boilerplate code that suddenly becomes obsolete when moving from, say, .NET Core 5 to .NET Core 6, for example? I don't know if anyone's had to deal with that. So I'm here to talk about let's NuGet all the things. So we all like to reduce code debt, One way is refactoring units of code, which is basically just taking an implementation of code in your application and putting it behind a class, which is great. That's programming. But it's not scalable when you're going from team to team, when you have to share that code around, copying and pasting, whatever. So let's talk about how we can reuse it across applications or your teams. We can create an API or an Azure function. Basically, you hide the abstraction over some sort of HTTP or TCP connection, something like that. Or you can create a NuGet package. Strictly speaking, .NET here. There's also NPM packages, different. We're talking .NET here. So NuGet package where you can at compile time reuse the code. Right? APIs are useful, but that's an entire other presentation. So let's talk about the NuGet packages. Firstly, why would you want a NuGet package over an API? Well, let's take a look at what else you can get out of a NuGet package. There's the obvious compiled code, right? By compiling it, you don't have to rely on a healthy HTTP connection. Now, there's nothing wrong with APIs. They have a use. But there are some things that would make sense to compile as code. But you can also package analyzers. Analyzers are implementations that review, analyze, and evaluate the structure of a program. And what this really means is you can inspect the code during compile time for quality, for style, for maintainability, and even identify runtime issues before they become runtime issues at compile time. There's another type of analyzer called a generator. Generators let developers inspect and append to code as it's being compiled. Like literally just generating code for you from scratch. It's kind of cool. We can also package MS build properties. Now, this is something that I know I haven't really gotten much into until the last year. So, MS build properties are name value pairs that can be used to configure builds, and it's basically like a variable for the project build. It's useful for passing values throughout the build process. One of the examples of a property that's going to be very useful later on here, that some of you may be familiar with, is package output path or publish directory. It basically says to the compiler, once you've built me, this is where I should live on disk. We also can package MS build items, which according to Microsoft's official documentation, an MS build item is a reference to one or more files. Items contain metadata such as file names, paths, and version numbers. I have found items to be a little bit not quite, in sync with their own definition, since they actually break parity themselves with item groups. But, that's none of my business. We can also package MS build targets. They're basically just functions for the pipeline, ways to abstract actions that take place during the process. We can also package templates, which are so self-explanatory that I couldn't actually find a single sentence in their docs that explain what they are. It's a template. You basically take files and folders, and you can create something new with those files and folders, duplicate it, like a template. You can, not only can you do that though, you can replace the name of the template. You can replace any variable you want in it, any value you want in it. You can choose what files to show or hide based on parameters that you put in. You could do so much with just a template. Then we can also package tools, which is basically just a console application run from the command line. The thing is though, because it's part of a package, just like any other package, if anyone's familiar with the GAC, we don't use that as much now in .NET Core. You don't need to. You used to have to have the DLL on disk in order to publish your code and all that stuff. But now you could just package it all up into one tiny little executable and run it because it's a package. Same thing with this console application. You can run this console application from the directory of your project that you're working on without having it downloaded globally to your system, which is kind of cool. The thing is, as you start to build packages, you find there's so much you can do in one little reusable package. So with that background, let's get to the fun part, which is the demo. Yes, we got an presenter here. Changing MS build props using the directory build props. So there's something called directory build props, which is something I discovered over this last year, which is very, very neat. I'm just going to show you what it is. So as I mentioned before, I'd like all of my packages to publish to one specific folder on my drive, right? I mentioned this package output path. So I'm going to use that folder as a NuGet package cache. So that way, once a package gets delivered to that folder, I now have access to that package in all of my other projects. Let's see what happens. Let's see how we can do that with the props. What is, oh, there, it's PowerShell covering that. So let's take a look at demo directory number 1. We got these build props. So there's this thing called the directory build prop, as I mentioned. It's got a little structure here of project, as you would with any CsProj. And we got a property group, and then we got target framework. But here we have package output path, the thing I mentioned earlier. The package output path is actually assigned to this file directory, published packages. So if you look at this over here, this the first example I'm going to show, it's called a project without output path. This is, I'm going to publish, and there's going to be no output path. I'm not specifying anything. I don't care where it goes. And you'll notice I have a directory build prop in the folder, but by having this file here, it prevents unintended imports, and that's kind of the point I'm trying to get at here. So let's take a look at what happens when I .NET path 1. Oh. What's that? Hold on a second. Oh, whoops, yeah. All right, so you'll see, .NET is compiling, it's restoring, it's going to go ahead and build a package, and then it's going to deliver it to bin debug project without output path .new package. If we look over here, you'll see we have bin debug, we have project without output path .new package. So let's take a look at the project without directory build prop. So the idea here is the first one had no output. Now it has an output, but once again, the file prevents unintended imports. So over here, we're going to go ahead and say that the package output path is this file directory / publish packages. restored, built, and published to project without directory props, build props / published packages. And if you look here in VS Code, you'll see there's this new folder that wasn't there before, project without directory build props. So that's just how build props works. That's just how properties work. So let's take a look at directory build props. So if you remember, oh, right here, this new folder just kind of got created. If you guys remember, we took a look at that directory build props over here, and it said it was published to this file directory / published packages. And as you can see, we have this new folder demonstrating directory build props .new package. And as I mentioned, my NuGet config has a reference to the published package source of published packages. So that is essentially directory build props in a nutshell. So next we want to package up some Manix build props as a NuGet package, right? We're here to talk about what we can package. What do we actually want to package is the real big question. We don't want to package the package out the path, right? What if you're on Linux, you don't have a C drive, besides just a technical idea, you don't want to dictate and mandate and say, hey, you should publish this package to this location, right? So with all that, let's talk about what we can package and what we want to package. So let's talk about analyzers. So first, we want all of our libraries to have the same code quality, so it's easy to go from one product to the next. So let's use Microsoft's recommended analysis. The next is we're building a public API for our company, or if you go on and take this with you, for the world. And so you don't want to have people who are developers have to read through your code in order to figure out what something's supposed to do. I've had to do that far too much in my journey this last year. But still, though, it'd be nice to have documentation and let people know at a high level what a function is supposed to do, any side effects, etc., any errors that are found. But also, I'm sure a lot of you have been in a company where you run a build, and all of a sudden you get like 300 warning messages, and there's one person in the company that's like, oh yeah, I don't worry about those. As long as there's not 301, then we have to look and figure out what that one missing is, but everything else. So let's keep our code base clean. So we have two projects here. We have creating a package and we have using a package. So creating package, it's a proj file, right? Up until now, everything you've seen is this is just general. You put it into the general build. This is a nuance that you kind of know about if you're basically not packaging up any DLLs, if you're only packaging, strictly content files, or text files, or whatever. So you don't really need to worry about that. What you need to worry about here, or know about, is you have this file. It must be the same name as the package ID, which in this case, package ID always defaults to the project name, unless you change it otherwise. And it must be packaged in build. Well, how do I know that it's got to be there? Just a brief aside. So if you're controlling dependency assets, if anyone's ever used any analyzers like StyleCop, whatever, they generally kind of suggest that you should set the private assets to all, or at least you should make certain assets private that you don't want to pass through. And really just compile is the lib folder where your code is compiled. Anything that is a props file or a targets file gets put into the build, or the build multi-targeting, or the build transitive, and those each have their own nuances, but feel free to ask me later about those The point is I'm going to go ahead and put it in the build. So here's that file I told you about. So, it's going to be here, and this is a file named by the same name. And all I'm doing here is giving the property group, the analysis, the stuff that I showed you on the screen. And if you remember, the directory build props, by being in the root directory, propagates up to all the projects that it maintains for. In the same sense, the package props propagate to whatever projects are referencing the package. So let's take a look at the package that's good. Well, let's start by building that. Oops, nope. I like .NET, but not that. I actually found out if you all capital .NET, it doesn't tell you why, but it doesn't work. So .NET pack. All right, so we have the package ready to go. So let's take a look at what we're going to be using for this package. So here's just the general package. Here is a class. I'm sure nothing, there's not much wrong with it that you might see at glance, besides it does absolutely nothing. Right, well, I mentioned that we want like XML documentation. That's a problem right there. Another problem is that hello test is not really used anywhere. And this is one that's fun. It's I guess opinionated. But because bar, this method doesn't really access anything within the class, it could be static. Why not? Why not just make it static? So let's see what happens when we build it. Just right away. Nothing happened, nothing wrong, still succeeded, but a warning here, just telling us that hello is assigned, but its value is never used. But the code's all ready to go. So let's go ahead and .NET add to and then package, creating package. Okay, so if I got that right, yep. Oh, I forgot. So one thing that I've been doing with the directory build props, actually, I haven't been doing this with the directory build props with here. That is version 1.0, isn't it? That's a fun coincidence. That is version 1.0. I've been setting my packages to 0.0.1 because they're not quite ready in pre-release. So I have referenced the package here. That's the point here. I've referenced the package. Let's see what happens if we build it again. The marriage. A lot of red is very hard to see a projector. But hello is assigned, its value is never used. And then later on it says a member bar does not access instance data and can be marked static. So let's go ahead and fix those errors.
Could you pass me the like to allow the code to be opinionated?
What do you mean?
Like, could you get rid of the compilation error that's saying that bar must be static?
Oh yes, you can change that. That is I will show you in a second. As we get back to the console, you'll notice here, does it say, error CA1822. So you can actually, there's something called an editor config, which will come up actually later. And if anyone's not familiar with it, it's kind of like the rule sets from back in the day as well. It's very, but it actually works for a lot of programs. It's more of a standard than the rule sets work, and you can set that specific warning to a suggestion if you wanted, or to none if you wanted. It's kind of nice. So let's build this again, and it failed again because missing XML comment for publicly visible type remember. Ooh. So I'm not going to make this build or anything because that's going to waste people's time with that. But the point here is that by importing this package, I was able to add these props. So, it's one thing to make this package, right? If this package exists, that's great, but who's going to use it? How do we make people in our company use it, right? If we're talking, building something for anyone else, anywhere else in the world, you can't really mandate things. But at the same time, well, you kind of can a little bit. So actually, I was going to bring this up in tooling, but there are templates for AWS lambdas and whatnot, where you can create a new AWS function just by running .NET new running templates. And so you're not technically enforcing it upon someone, but you're saying, hey, if you're going to use our product, it would be a good idea to use this template. But let's take a look at templates in action. So I mentioned that it's just files. So some people who are watching and who are here don't actually do C#. I've sent this to a couple of people. And they might be in a different area of code. Java. Some people might be doing PHP. Some people might, I don't know, project managers, I guess. And so the thing is, templates are just files and folders that you move over. So let's go ahead and take a look at packaging a template with nothing but a markdown file. That's not code. That's not C#. There's nothing .NET-y about that. That is, right? So we have here a format date, which is a template, little token that I created. So I want to create a retrospective so that I can always pop open this, create this new template and say, hey, let's create a new retrospective on this date. And I want its file to be named whatever the date is. Notice once this file date, once this format date, there are going to be two different formattings. So how does that work? Well, over here, we got the file date, which is generated by now, formatted to year, to month, day. So it's going to be like the numbers, followed by the numbers, followed by the numbers. But then over here, we're going to have month, month, which generates to the full text, so October. That's what the format date is going to be. Oh, yeah, it'd be if I didn't give a little nod also. So I actually was talking with someone from, there's a podcast I listen to called Coding Blocks. I really like it. And so there's this guy, CsProj on there, who I was talking to him about it, and he actually said he uses this to generate show notes for his episodes. Like he has 5 podcasts, so like .NET New, Ask a Brit, .NET New, Dev Otaku, or whatever, and it helps kind of organize things and keep things moving. That's kind of what gave me the inspiration here for the Markdown as a simple example. So .NET Pack 3. So the way that you install a template once you have it is that you're going to install new install. So you got .NET install if you're installing a package on a project, and here you're going to be .NET new installing, and it'll install globally demo.retrospectives. As you can see here, we have a new retro. So I'm going to go ahead and so we got a new folder here, retrospectives. Let's just find that folder here, open it up so we can see what happens. I'm going to go ahead and .NET new retro. We have 2023, 10/18 retrospective, October 18th, 2023. Participants of this retrospective is Eddie Lichtman. Since I have this new retrospective, I'm doing things. I'm going to say Joey is here with me at this retrospective, and we can keep moving with whatever we need to do once the template has been created and it doesn't change the original version of it. So it's just branching from what you had originally. So templates, pretty cool. So let's talk about minimizing the daily grind with automating tasks. I mentioned about .NET tools being basically just a console application, right? Well, I also mentioned about Amazon Lambda tools. It's a tool called Amazon Lambda Tools that might be useful for some people who use Amazon Lambda. It's just a .NET CLI for deploying the AWS functions. You can install it globally. Talked about Cucumber and SpecFlow. There's also a newer end-to-end testing framework called Playwright. Microsoft Playwright CLI is another .NET tool. There is, if anyone's familiar with Open API specification or Swagger, basically it's just once you create your API, it's a specification that creates JSON, and that JSON can be read by machines so that you can create definitions. How do you create those definitions? With tools, NSwag, Refiter. Those are all different tools that you can use for creating and generating a client for your .NET application. And then there's one that's very near and dear to my heart called Nuke, which they label themselves as an ache-less build system for C#, which is a bit of there's two reasons for it. One, if anyone's familiar with make files or C make or cake, C# make, right? There's a whole bunch of these different build systems, but then there's a little bit of that tongue-in-cheek, it's a build system without the aches and pains that you have to go through to enable it. So there's plenty of different tools out there, and in fact, you can find them, templates and tools. Check this out. So I'm going to search for packages. Doesn't matter what I'm looking for. .NET tool, Cake tool, Git version tool, Microsoft .NET Interact, .NET EF if you're building the C# using Entity Framework. There's ways you can add migrations and whatnot. That's a commonly used one. And then we can look at the templates right here. Microsoft Azure Web Jobs, project templates, right? You got all these different templates and tools. And back to the templates here, if you look after you've installed Visual Studio on disk, .NET new list, you got all these templates that are already pre-installed. Just the thing is, if you're ever in Visual Studio and you're like, hey, I want to create a new something, all those somethings that you see are what's in your tool, or what's in your template, actually. So, back to tools though. So, like I said, it's a console application. So we're not building the next Lambda tools, deployment tool. We're not building an entire build system. We're going to build hello world. The time now is whatever the time is, and thank you all for being here because I do appreciate it. So the only big difference between every other Proj file that you've seen now and this is the redundant root namespace, which I could probably delete, it'll work, but I'm not going to attempt the demo, guys. The package ID, which, again, same thing, but it's an executable. That makes it a console application, along with the fact that it has a program CS file. You can pack as tool, and it has a tool command name. Those are, like, once you build the console application, all you have to do is add these two things, and you now have your tool that can be packaged up and shipped to NuGet, your internal NuGet, public NuGet, whatever you need. So we're going to go ahead and .NET pack. And so I also mentioned that you can install a tool to wherever you want, and it doesn't have to be global. So .NET tool new, back to that template, tool manifest. So that's how we start the tool manifest. We're going to go ahead and .NET tool install demo time. As you can see, this very hard to see green on this projector. This does not do color as well. You can invoke the tool from the directory using the following commands: .NET tool run demo time or .NET demo time. So let's do that. .NET demo time. Hello world, the time is 7:06:56. Thank you all for being here. And as I mentioned, it's not global, so what happens if I change directory? Like the parent. I run the same command, demo time. Did I misspell it? Is it not there? It's confined to the folder that it was installed in. So putting it all together, we're going to build a package library, right? A series of libraries that are all, in one area so that we can kind of build things off of each other, keep things succinct, right? I showed you how one file, you can propagate all of these different properties to the different projects. So if you noticed, a lot of the packages that you've been looking at have nothing in them. Oh, the projects even have had nothing in them. Well, I kind of like it that way. We were talking about reacting, a little bit opinionated and all that stuff. It depends on what you want to keep out of there, but there are some things that are nice to just not have all the clutter and allow the CsProj file to just hold all the information about the CsProj file, right? You don't care how it's being packaged. You don't care that the copyright is your company. You don't care that the author is yourself. You don't want that to add to the clutter of building your packages. So let's first, let's go ahead and we're going to make sure that all of our libraries use the latest lang version because they keep putting out good stuff. Let's use it, right? The other thing is nullable reference types. I've really been a big fan of nullable reference types. So some people aren't, and you can always disable it after it's been enabled, right? You're importing these props, but you can always change it after the fact and say, hey, I don't want nullable reference types. Let's configure code analysis. I mentioned style top, which is an analyzer. So we're going to configure that, and I mentioned the editor config. Actually, that kind of tied in really well. So there's some preferred rules. You're actually going to get to see an example of what it's like to configure the editor config, and that number CA3128, maybe whatever the number was. You can imagine what it's going to look like in that file. Now that you know about it, I'm going to once again treat the warnings as ears because it's a good thing to do. It's everything good. We're going to include some suggested tools. So one of the tools I didn't mention is .NET Outdated Tool. So we're going to be having packages and packages and packages and packages. And how are we going to keep up to date? Are we going to have someone just looking in the NuGet, package manager, going through every single package they've installed and making sure that it's all up to date? Or do we use something, a tool, that's there to tell us, hey, this package is over 90 days old, failed build? Also, automatically update the packages as needed. It's probably still a good idea to review each of them. You can also filter. It's a very cool tool. And then we're going to bypass all the boilerplate code with a template, right? We're going to have a recommended folder structure. We're going to automatically enable the latest long-term support. The one thing is that you cannot, anything that affects the build process in regards to what packages you download, you cannot package up. So you cannot affect the framework because in order to download the package, it needs to know that the framework is Net 6.0 and that the package is allowed to be on that project. So inside the template, we're going to automatically enable Net 6.0. And we're not going to put Net 7.0 because it's not in long-term support and we have customers. And we want to be able to, not in a year from now, have Microsoft be like, hey, we're canceling support for this, and then have us have to go out to all of our customers and say, hey, are you cool with upgrade? Are you cool with upgrade? So I think it'll just be easier to close this and open the final demo. No. So I mentioned the assembly annotations package. We're going to start off with this source. I showed you before that building a package, you just have a build file. We're going to have a props and a targets file. I mentioned the props file. The targets file is run in the build pipeline after the props have been run. And so there's nuances to when you can use one, when you can use the other, and what can be run in one or the other. But it's also just, according to the docs, better practice that certain things are run in targets files. So we're going to say lang version is latest, nullables enabled. We're going to generate that documentation file. We're going to disable the implicit usings. I personally think it's too much magic, and you have seen a lot of magic tonight. So that is a little bit of a, the point is, like I mentioned, somebody could always enable it if they want. The platforms are going to be running CP 64. That one is a little bit weird. I feel like I should take that out just because there's a whole affecting the build thing in S60, but it seems to work. But I'm not going to be messing with the demo guys here. And then generate assembly info is going to be set to true. Now, here's a cool, neat little thing. If you've ever built an internal class or function or property, how do you test that? If you just test the output, you run through the whole process. Well, you can actually, a lot of you might be familiar with the assembly info class where you have an internals visible to attribute. In .NET Core and .NET Standard, you can actually set this internals visible to, which during the MS build pipeline automatically generates the attribute that I was mentioning in the class. And so here, it's pretty clear that if an assembly is named assembly name dot integration dot tests, it's either the use case for it is going to be integration dot tests, or somebody's going to have a really questionable code review. And now, before this specific target, we're going to set the author to be Eddie Lichtman. The package ID is going to be the project name, because you can change the package ID. But why would you ever want to? If you're looking at your packages and you're saying, hey, there's a bug in this package and you need to update it, why would you want to go to this other code with a different project name? I understand there might be a reason, but not for the libraries I'm building. That is another opinion. But over here, we're not overriding, we're appending to. We're going to say whatever the package tags were, let's also add it's a common library and it's part of my demo right here. Then we're having this copyright of Eddie Lichtman, system date time now, year, string. So that's just the annotations. Let's take a look at the code analysis part. So over here, we're going to go ahead and we're going to include all of these content, which includes, I mentioned everything in the build, and this is the first time you're seeing I'm going to be putting stuff in the content folder. That's going to include the style top JSON and the analyzer config, which is the editor config. There's differences, but anyway. But I'm also going to reference style top analyzers, and I'm going to set the private assets to none. What that's going to do is it's going to say that none of the analyzers that style top would run are going to run in this package, and instead anything that references this package automatically must import style top analyzers. So we're going to go ahead and look at the content. The style top JSON is just style top JSON, and the analyzer. So .NET Diagnostic .IDE 0007, or in the case of the other one, CsProj 3.1.3, I think. Severity warning equals whatever, right? So we're gonna have our different analyzer here, different rules. But let's take a look at the props here. Treating warnings as errors, as I mentioned. A better level of treating warnings as errors. Code analysis treating warnings as errors. Analysis level latest recommended has. Yeah. If you're building this, it's going to enforce the code style and build. I don't know. I think basically, if you notice, I built it and then it failed, and I fixed the things that failed, and then I built it again, and then it said XML. It was missing its XML. This says all of the errors come in at once, flow in at once. So it's not going to build once, wait to see whether or not the code style is there, the XML is there, it's all. And now the way that style cop works is that you need to add an additional file. That additional file has to be a style cop JSON. And so when this file exists in the package, it's going to exist. Let's take a look here. See source. Gosh. There we are. So if we take a look at our packages cache right here, let's take a look at demo assembly annotations. Inside of demo assembly annotations, there's that build folder I mentioned, and inside that is the props. Let's take a look at demo time. Inside of demo time, there's this tools folder, and then there's the net7l and the any, and that's where the DLL is. And so the point here is that whatever this file, this folder resides in, so it's going to be in build, it's going to be in build transitive, it's going to be in build multi-targeting. I don't use that one very clearly. The parent directory of that into the content directory, it's going to reach into style cop JSON. Same thing with this analyzer here. It's going to look into the parent directory content analyzer configuration. So that's for the props. Now the next thing is, if we're building a package, we want it to have a description, right? A package must have a description so it can be well understood. So that's it for the code analysis. And so now let's take a look at the template. The template is basically, we got a solution file, we got a source, package library, we got the references here. There's something called central package management, which is kind of neat, where you can manage the version that you want for each package in one central location at root, similarly to how the build props lets you manage the whatever you want in the build at the root. So over here, you'll notice there's no version. That's the reason I bring that up. So I referenced the package of assembly annotations and code analysis. We got this tests of integration and of unit. And if we actually take a look at the config file, we have this .NET outdated tool that I mentioned. And then if we look at the actual template JSON that builds all this stuff, you'll see we build everything, and then we have some modifiers. So we can exclude some folders, right? We can exclude the unit tests if we have this skip test set to unit. So what does that really mean? If you look at the symbols here, I have a package type. So we're going to have root. And the difference between root and leaf, if you've ever worked with Microsoft extensions, if you think about it, like, I'm pretty sure that all of them get versioned at the same time. You're always going to have version 6 and 7. I would consider Microsoft extensions to be a root, but for the sake of argument, you could say that Microsoft.extensions.logging is the root and Microsoft.extensions.logging.abstractions is the leaf. So the idea here is you have some things that will show up in the root folder, like the directory build props, and then you have some things that won't show up in the leaf folder, like the directory build props. Skip tests, let's say you're building an abstractions library. You don't care about unit tests and integration tests if there's only interfaces. And then post actions. You can basically say, once you've created a leaf package, let's add that to the root solution. And so let's see that in action here. So we're going to start with .NET pack. We're just going to go in change directory to final demo. .NET pack assembly annotation. .NET. Go with that. .NET. You notice the 0.0.0.1 .NET pack templates. So one of the interesting things that I'll also show you real quick before I get too much further into the demo, or fun things that I'll show you, is if we look at the actual template here, we don't import assembly annotation. Well, you know what? I'll show you once we've actually built the package. So make directory packages. Change into packages. We're going to make directory test. And so here we're going to say .NET new install, because I haven't actually installed it, demo.templates. As you can see here, now I have a new demo lib template. So we're going to say .NET new demo lib help. Let's see what we got here. We got the name, so I'm just going to keep it test, the name of the folder. But then we have package type, which is required. Then we got the skip test and is cross root that I mentioned. So we're going to say PT is root. All right, let's take a look at this package. We have a solution file, and in fact, we can open that solution file in Visual Studio. I hope. Oh, cool. Sounds like my stuff. All right, so inside of this, we have this test project, and inside of the tests, we have integration and unit. And let's go ahead and build that make directory abstractions. And then we're going to say .NET new. And say name test.abstractions. I haven't figured out how to do like an automated way of just saying whatever the previous folder's parent was, but I'm sure there is one, and I'm going to figure it out. But the package type is going to be a leaf. And then I'm going to skip the integration test, but I'm going to keep the unit tests. Skip tests integration. Oh, whoops, I forgot to actually get the demo lib, the template code. So it created a new project and it added it to the solution file. This is going to ask me to reload. And as you can see here, we now have test and test.abstractions. We have test.integration tests and then test.abstractions.unit and test.unit as promised. And then let's go ahead and let's build this. Let's pack it. Even though there's nothing in it. Oh, wait a second. Oh, yes. What does that say in red? Package. Oh, no. Package must have a description. so it can be well understood. That's why I can't package it. So let's go ahead and say a project file. There we are. That's good enough. And then there we are. Let's try that again. There you go. So the thing I was going to show you that I said was another neat thing to kind of note, as it is technically part of this demo. Let's take a look at that package we just put. Not many people might know this, but new package files are just zip files. They're just archives. And inside the archive is the lib that I mentioned, the compiled code, the DLL, and it's a new spec file. So let's take a look at this new spec file, because I promised some package information this time. I do not want to always open. Let's just go ahead and
It's always open.
yeah, but on Notepad. I didn't want to always open on Notepad. That was the important part. Here we are. The ID is test. The version 0.0.1. Notice how I didn't have the version 0.0.1 anywhere in my CsProj file. And in fact, we can take a look here. It's not in my CsProj file. That's because it's in the directory build props, as mentioned. So back to that file. Author is Edward Lichtman. Descriptions of test logic. Copyright Edward Lichtman 2023. Functionally created the year. And that there you go is the package. It can be imported. It does absolutely nothing except entertain you for the last hour. Okay. So here we are. Oh, battery. You might want to plug in your PC. Hold on a second. So yeah, basically I mean, that's kind of basically it, right? To recap, NuGet packages is so much more than just compiled code, right? You got all the stuff. It's crazy once you really get digging into it. Thank you all for your time. I hope you got something out of this presentation, even if it's just to come visit my band October 28th. Talk to me after if you're interested. You can buy some jam and support the band at the concert when you go there to support the band at the concert. But I hope that you can actually take some of this amazing technology back to your workplace. And I have time for questions, and if I have time for questions after one-on-one, yeah, that's it.